Okay, here we have a photograph of rocket, and they say the rocket's engine give a total upward thrust of 7.3 10 to the power 7 newtons. Calculate the initial acceleration of the rocket. Mass of the rocket is 5.0 times 10 to the power 6 kilograms, right? Okay. If I draw a free body force diagram, here is our rocket, right? And this is our weight, and here is our what? Upward thrust. Let's call it Fn. And according to F equals ma, our rocket will accelerate toward this direction, and we all know sigma F equals ma. What is this sigma F? Is the resultant force acting on the rocket, or we can take it by taking the vector sum of all the forces acting on the rocket. uh, and they have given us only the mass, so we have to calculate what is weight. So W equals mg, so starting from here, mg, and mass is 5.0 times 10 to the power 6 kilograms times g is 9.81 newtons per kilogram, right, per kilogram. And if we simplify this one, you will get 4.91 times 10 to the power 7 newtons, right? Then we can apply what? F equals ma, right? This is the direction of the acceleration. So F equals ma, and F should be the vector sum of the forces acting on the rocket, the resultant. Then we will get the resultant, right? To take this vector sum, right, I'm going to take the vector sum of all the forces. So we have two forces, and forward thrust is acting towards the upward direction, so it is positive, and weight is opposite to that direction, so it is negative, because we all know vectors have directions and magnitudes, right? um, then our thrust is 7.3 times 10 to the power 7 newtons minus our weight 4.91 times 10 to the power 7 newtons. If I explain it again, here this is positive, why it is acting towards this direction, and here this is negative, why it is acting towards this direction, opposite to that direction. So if we take the F, which call the resultant force acting on the rocket, uh, that will give us 2.39, sorry, yeah, 2.39 times 10 to the power 7 newtons. Now we can apply F equals ma, because we know the resultant force. Then 2.39 times 10 to the power 7 newtons equal the mass times acceleration. Mass is 5.0 times 10 to the power 6 kilograms times the acceleration. So you can take the acceleration. If you take the acceleration, you will get 4 point, if you simplify this one, 4.78 meters per square second. That is our acceleration, right? So you will get marks for finding weight. Over here you can clearly see it is 3 marks. One is for that one, and one is for using F equals ma, finding vector sum, and for your final answer, right? In the next one, here part B, they're asking give one reason why the acceleration will increase as the rocket rises, right? You can clearly see our equation, and it is, this is the resultant force, or you can write it as upward thrust minus weight equals ma, sorry, right? So if this one is increasing, this one is decreasing, right? They say acceleration will increase. If this one is increasing, right, if this one is increasing, this one should decrease, right? we cannot increase this one because this is the upward thrust that we are giving, so weight should decrease. So is it possible? Right? Yes. The reason is the mass will decrease, or we can tell weight will decrease. Why? The fuel is used up while it is moving upward. That is the reason. So you can write the mass or weight, right, decreases. Why? Fuel is used up. Fuel is used up, right?